Hi everyone, in this video I want to explain how you can configure DMVPN Phase 2 with IPsec. DMVPN, as you may know, Dynamic Multi-Point Virtual Private Network, is a scalable method, a protocol, Cisco proprietary protocol that you may use in Cisco environments to build a secure tunnel and a scalable tunnel by means of GRE or MGRE multi-point generic routing encapsulation for encapsulating methods and as a tunnel method between these sites, different sites, as an overlay network on top of the um, underlay network, like this transport media, for example, the fast internet here, or maybe in the in some other environment, fiber. You may use fiber optic technology as a underlay or transport network technology, and by the means of DMVPN, we can connect logically all of those sites together. And here in this scenario, we need to connect central office resources with branch office number 1 and branch office number 2. But the main point is DMVPN uses another component of DMVPN is NHRP, next hop resolution protocol, that's uh, gives us an ability of on-demanding address mapping of different spokes dynamically. Spokes needs to find each other IP address to connect, to build it GRE tunnel between each other. But by the means of hub and spoke scenario or design, NHRP gives us the ability to find the IP address of each spokes from hubs. NHRP in some way act as an ARP protocol, address resolution protocol. The main task of NHRP is to mapping address to each other. Also, the main important thing is DMVPN will work with three different phases or three different designs. And when we think about the design, DMVPN can configure with each of these uh, phases, phase number 1, phase number 2, and phase number 3. The most efficient phase and scalable phase is phase number 3. And if I want to say that the name of those phases to you, let me say that DMVPN uses, you can design with each of these phase. Phase number 1 name will be hop and a spoke, or hop to spoke, something like that. Phase 2 that I will show you with this video, it's about a spoke to spoke. And with the phase 3, we may use a hierarchical spoke to a spoke. Excuse me, hierarchical hub. No, hierarchical spoke to a spoke, I think. Today I am going through the phase number 2 plus IPsec as a tunnel to keep GRE or MGRE multi-protocol generic routing encapsulation traffic safe, because GRE or MGRE by default do not use a method for encryption or something like that. MGRE and GRE keeps traffic clear text in a plain text, but the main goal of GRE is to one of the main goal of GRE or MGRE tunneling protocol is to pass or transport multicast traffic, because By the means of multicast traffic, we can use dynamic routing protocol to use for routing between each of these router to route those networks. So as fast as I can, I go through the configuration. So first of all, I am issuing um, show running configuration. I just configuring the DHCP for uh, each of those LANs, an IP address for the WAN interface with this IP as a WAN IP address, or in a real environment, if you connect to the uh, internet's WAN network, you can use the public IP address here, and also the LAN IP address. This IP will act as a gateway for its central office local area network. And if I go through spoke 1, you may see that we only have a DHCP server, and excluding the gateway IP address from the pool of DHCP, and the WAN IP address is 10.1.13.2/20/30, and all of those interfaces, the state is up and running with the no shut command. This is a LAN interface, and I have no configuration there, extra configuration I mean. And here also the DHCP for this LAN, the gateway, default router for acting as a gateway for that broadcast domain, interface fast Ethernet 00 IP address as a WAN address, and the LAN IP address as a gateway for that specific LAN. So let's deep dive into hop configuration. First of all, I want to configure a tunnel interface. So I will go through interface tunnel. First of all, IP address. The IP address of the tunnel should be something like this. The slash 28, it means 240. No IP redirects, because this IP redirect configuration is just suitable for usable for uh, DMVPN Phase 3, and we don't need it here anymore. And IP source should be, you can choose the you can configure the WAN interface, or in this case I prefer to use my WAN IP address. Tunnel mode should be GRE multipoint. I will choose the authentication key for our NHRP protocol. IP NHRP map multicast or multicast, because we need to dynamically the NHRP map the addresses of address of folks. IP network ID is very important because you can choose different network ID in your case, but in my case, I use 121, and this is really important command. If you forget to configure this command correctly on each of those sites, none of these sites can communicate and can build a GRE tunnel between each other. So this is a really important command. IP NHRP NHS should be the IP address of mine here in the the IP address of the hop node. And I think here is enough for now. Let me confirm it with show IP interface brief first. I need to be sure that every interface will be up and working. Then show running config interface. Tunnel 0 will give us the configuration. So everything is working fine here. If I confirm it myself, if I call my router with my IP address, so it gives us a reply back. And also in addition, I want to go to spoke number one. Let me go to spoke number one and configure the interface tunnel 0. The IP address should be 172.16.16.2, 255.255.255 and 240. Tunnel mode GRE multi-point and should be my WAN IP address. IP NHRP authentication should be AMIN 123, the same as other side. IP should have to solve the other side of the tunnel of, the hub and map it to its WAN IP address. IP NHRP NHS or next hop server should be the WAN IP address of, the tunnel IP address of hub. And I think here we are done. Show running interface tunnel 0. That gives us okay. The main point that I forget is this one, interface tunnel 0, and the IP NHRP network ID should be this one. Now let me confirm it with a ping. No worries. Let's configure a spoke. Let me check. Show interface tunnel 0. It is open working. Show interface tunnel 0. It is also open working. The IP address is the same with the same broadcast domain. This is the correct WAN IP, and tunnel mode is correct. Source is right one. IP NHRP NHS is IP address is correct, and 10.1.12.2 is also correct. And okay. Look at here. The main point is, first of all, honestly, I should write a default route to our next hop, to our ISP on each of those sites, because if these two here cannot ping each other, so they can't build a tunnel between each other. This is your route to its default gateway. We will name it default route. That's great. Now Now these two can ping each other and also build a tunnel between each other two. Let me check that with the, let me confirm it with its WAN IP address. And also from there, um, is a two-way protocol. And both of them should ping each other right now. Okay, everything is working fine, correctly between these two nodes. Let me go back to spoke number 2. First of all, I remember that I should create a default route first to my gateway. Can ping other side or the remote end of the tunnel, then we will go through the tunnel configuration. To specify the IP NHRP network ID command, then I will confirm it with IP show IP interface brief. Okay, let me check that. Everything is working fine here, and our GRE tunnel between each of them connected, now connected correctly. In other hand, we will go through IPsec. We need to configure IPsec. So first of all, let me come back to hub and going into the global configuration mode. Crypto IPsec ISAKMP policy, specific policy, number priority, number, and encryption method will be, for example, triple this, but the best way is to choose AES. Hash method is here I choose MD5, and also the DMVPN group, we can create different type of group. For example, group number 5 with the most um, the secure way than, for example, group number 2. But I choose group number 2, and also the authentication method should be pre-sharing key in my scenario. With the ISAKMP key, I have to specific name with the here that I want to build a IPsec tunnel. If I here we should specify the public or the public IP address or the WAN IP address of spokes. If I specify the tunnel IP address, it means that the GRE tunnel cannot traffic cannot protect it with IPsec. So this is really important to specify it carefully. Crypto IPsec, we need to specify a transform set my transform set, and with the yes, for example, I don't know, for example, triple this and back, and also the tunnel mode. The mode should be tunnel. Now we should create a profile, specific profile. We don't need to use a default profile. My profile, and set the transform set to my transform set that I created before. And after that, interface tunnel 0 will be, let me explain it after completing the scenario. Let me copy it from here. And edit it with the hub IP address. Confirm it with the show run command, and we should see the correct configuration here. Everything is working fine here too, and also with the last one. Okay, everything seems fine, but the main point is we need to uh, you can do this before the IPsec configuration. You can do this after the IPsec configuration, but the main point is creating a planning to use a routing protocol between these three routers, between these three sites, to route the LAN packets to each other. In this scenario, I will use OSPF. So I will go through the OSPF by this command router. I bring in the first, in this scenario, I just only need a one instance for OSPF. I bring the engine of OSPF up with this command. Let me specify a wildcard mask, and also I choose a single area design, and the wildcard mask of /28 should be 000.15. Now, the most important thing here is interface tunnel 0. I should issue this command, IPOSPF network type broadcast. This is really important for DMVPN configuration on those situations that you use OSPF. And let me go back to the spokes to specify a OSPF. They're trying to make a connection between each other, and also network 192.168.1.0 slash 24 or wildcard mask, something like that. Okay, one tunnel is running in a full state and another one will be running in a full state too. Let me check that. Show IP route to confirm the routes that came from advertised from our neighbor. This is a route that's advertised from the other side of the tunnel by this neighbor. And after a few seconds, another neighbor will comes up. And the most important use OSPF and DMVPN is to, that's great. Look at here. Both routers will elect as a not election communicate as a neighbor. So with the show IP OSPF neighbor, we can show IP route. We can confirm each route of each network, and also if I connect with the password test 123 with T uppercase T. This is a Linux machine mint over here with the IP address of 0.3, and it should be able to ping to communicate with the other side or each side in this network through the tunnel, which we are not complete yet. Okay, it means that we can ping each other. We have to ping each other right now. Okay, no worries, because we need to configure, let me check. And also the most important thing is to prevent spokes to participate in a DR and PDR election. But after a few seconds, you may find that after the routing tables of each of those routers updated, then they can ping each other without any problem. And also we can confirm it with a trace command. It should be 0.3, and it says that from here I pass the packet to my gateway. After that, from the other side, I will send it to the other side of the tunnel, 16.16.2, and after that it will reach to the destination. But the more important thing is, with the spokes, we should goes to tunnel and say IP OSPF priority should be 0 to prevent from participating in the DR and BDR election. So everything is working fine here. Now the most important thing is, until now, we're just configuring DMVPN without IPsec. I just configure IPsec, but we don't say our GRE or MGRE tunnel protected with this configuration, with the IPsec. So after I explain, I have to go to under the inter-tunnel interface and specify the tunnel protection IPsec command to pass GRE traffic or MGRE traffic through the tunnel. But after that, we will see that the neighbor relationship between all of these three routers will goes down, and then we will go through, uh, you know, specifying why we will see this happening, and then we will uh, uh, continuing with the correct configuration. So interface tunnel 0, IPO no. The IPsec and with the profile, that profile I choose it or I specify it here in this section, my profile. And after a few seconds, you may see that the uh, OSPF neighbor relationship will face with a problem. IPsec with the profile. Okay, now we will see that OSPF neighbor relationship will face with a problem between each of them. And because of that, after 40 seconds, um, the uh, neighbor dead relationship, you may find that you may receive that the neighbor is dead, but after 40 seconds for each of them. And the point is, we have to, by default, IPsec don't let any traffic pass and comes through inside each of these sites, and we have to create the access list. Look at here, we have to create an access list for each of them. After 40 seconds, you may find that, and also if we confirm it, we can confirm it with the show IP route, and we will see that those routes that OSPF brings to us is gone. Let me check. Issue the ping and look at here. You cannot ping anywhere. Any LANs cannot communicate with each other. But after a few seconds, let me issue it here. And after, I will configure an IP access list for it. Extend it with a number. I easily use a whole UDP with any source and to any destination, but you have to specify an exact traffic just only for IPsec and each traffic that you may want. This is not a correct and safe configuration that I am using. And also we need to permit GRE from any source to any destination. And after that, we have to come here to this interface. In inbound direction, we should permit that accesses. We should attach that access list to it. Interface fast Ethernet 00, IP access group 100N, and we should configure the same on both of those two routers. Let me copy the access list. IP access group 100N. And if I want to show you the configuration from the spoke 2 side of view, this is the correct configuration. This is the IPsec configuration. That one is a GRE or MGRE DMVPN tunnel configuration. This is our interfaces configuration. The OSPF, or you may use EIGRP and something like that, ISIS or something like that, RIP even. The default mode, access list, and the most important thing is IP access group 100N. But show IP OSPF neighbor shows us the initialization state, and if we sometimes we need to uh, reset, clearing the resetting the connection tracking of each of those routers. As soon as you configure IPsec, or as soon as you configure firewall or access list in a router or in a firewall, those devices look into the keep tracking of the connection on their connection tracking. And by this, if on those situations that you may face with a problem like here, first of all, write your configuration on all of your routers and then reroute them. Restart those routers, and after those routers comes up in this environment, I think we should start them by manually. Okay, they reach to the two-way state with the OSPF neighbor relationship. And after a few seconds, they must reach to the full state connectivity. Okay. Okay, they reach to the full state connectivity, and after they advertise their routes to each other, we should see something like this. It means that this flag means that this routes comes from a OSPF neighbor, comes from OSPF router. And look at here, everything now works fine and correctly. So this is about the DMVPN Phase 2 with IPsec. In the next video, I will go through the Phase 3 with IPsec. Thank you. I have to say thank you for watching this video.